This video is over topic 24, numbers 1 and 2, finding area given z-scores. So in ALEKS, you will have, anytime you need to do this process, you will have something that says use this table or the ALEKS calculator. So use this table, you click on this, you get this table. The table tells the area to the left of the z-score. That's super important to know. It tells the area to the left. If you're needing to find the area to the right, the area between, anything like that, you have all the details of those calculations here in this table. And we'll do examples. You can also use the calculator. So the ALEKS calculator, you come here, you use this button, you put in the z-score. You then have to do the rounding. You always round to 4 decimal places. And you should also round the z-score to 2 decimal places before you put it in. All right, so we have some examples here. We're looking at between, so comparing the z-score table that gives more precise areas versus the empirical rule. So if I look at this table, I'm just going to go ahead and look up all of these z-scores. So we have -1, +1, -2, +2, -3, +3, and we're finding the area to the left of each of those. So -3, that's -3.00 here is 0.0013. And I keep going, -2.00 is 0.0228. And going back to the next column, -1.00 is 0.1587. Then +1 over here, +1, 0.8413. +2 here, 2.00, 0.9772. And +3, 3.00 is 0.9987. Notice these opposite pairs, -1 and +1, -2 and +2, -3 and +3. If you add them together, it equals 1. So that's corresponding to, well, yeah, that's relates to one of the ways that you can go about doing if you need the area to the right. But for area between, you subtract. So it's going to be area to the left minus another area to the left. So between -1 and 1, I take the larger area, always larger area, minus the smaller area. For -2 and 2, larger area, 0.9772, minus the smaller, 0.0228. And for 3 and -3, 0.9987 minus 0.0013. So let me throw these in my calculator. 0.8413 minus 7. All right, so we get for between -1 and 1, 0.6826. 68% is the nearest whole number, but it would actually be 68.26% would be more precise, but it's rounded to 68%, not too far off. For the -2 to +2, the 95% region, it would be 95.44%. So you could argue that should more so be rounded to 95.5. It's kind of stretching it to round it to 95. But it is rounded to the nearest whole percentage. So again, you see where that 95 came from. And then for the middle 3 on each side, the 99.7%, that was already rounded to the nearest 10th of a percent. It's 0.9974. So 99.74 to be a little bit more precise, making it even less if we went outside of that. It's even less than 0.3. It's like 0.26 of a percent beyond 3 standard deviations. So generally, you can assume anytime you see it say this table, you should be using the z-score and the table and not using the empirical rule. All right, some more practice finding areas. So do not just look at the z-score, open the table, get the area. You have to pay attention to what it's saying. This is the area to the right. The table gives the area to the left. So if I look up 1.70 on my z-score table, 1.70, here we go, 0.9554. So I'm going to draw a little picture. Here's my 1.70 z-score. This area over here is 0.9554. I want this area. So one way to do that is to say, well, I want everything except this. So I want to take 1, the whole. So again, all except the 0.9554. So 1 minus 0.9554. The other way is using the fact that normal distribution is symmetrical. So here's 1.70. I want this area. If I reflect it, if I put negative 1.70, so the same amount in the opposite direction from the mean, the area to the left, which is what the table tells me, of negative 1.7, those areas are equal. So if I could look up negative 1.70, that will give me the same thing as I get if I subtract. Right, so I can do either this calculation or I can do this, looking up the opposite sign. But the answer to this area is 0.0446. Read the words, don't just take the number. And draw yourself a picture, because hopefully you can recognize this area here is not 0.9554. That would be 95%. This is a lot less than 95%. All right, between. If it's between, you're going to look up each z-score. And then you're going to subtract those results. Do not subtract the z-scores with each other. You have to look up each z-score individually. You subtract the areas. So negative 1.75 here is 0.0401. And then 1.50, let's see where that is. Here it is. 1.50 is 0.9332. And then we subtract 0.9332 minus 0.0401. And that's 0.8931. All right, and then just for fun to show you the other way you can do this, for the area to the left of z equals negative 2.20, you can just directly look it up on the table. You don't need to do any extra stuff, but I can also go here, use this p z is less than or equal to button, type in the negative 2.20, and now I have to just do the rounding myself. It's 0.0139, 4 decimal places. Next digit's a 0, so I don't need to round up. So that's finding the area when you're given the z-score. You have to pay attention not just to the z-score, but the words that tell you what area you're actually looking for.